Okay, so notes 12 is going to be adding and subtracting rational expressions. So remember in the last notes we did multiplying and dividing. Now we're doing adding and subtracting. So anytime you see rational expressions, I do want you to think fractions, right? So when we multiply or divide fractions, that was the same way as us multiplying or dividing those rational expressions. Which means when we're adding or subtracting rational expressions, we're going to do the same thing as we do with fractions. So if we're adding or subtracting fractions, we have to make sure that they have what in common? The denominator. So we're going to do the same thing with these rational expressions. Make sure the denominator is the same. And that's what this part is saying here. It says let P, Q, and R represent polynomials where Q is not equal to 0. So this says that if we are adding or subtracting, as long as they have the same bottom number, that same denominator, then we're just going to add and subtract the numerators to get our answer. So for the first one, we're just going to practice with just fractions. Okay. So in these ones, it's just saying, okay, can we add 1/2 plus 7/12? Well, as it is, correct, we couldn't do it. So we would have to get a common denominator, and what would that common denominator be? 12. So it'd be 12. So it's thinking, okay, what number can I multiply both of these by to get the same number? So here I can multiply this whole fraction by 6, both the top and the bottom. And when I do that, I get a common denominator of 12, which means do I have to do anything to this fraction?
I mean, technically multiply by 1, right?
Technically, yes. Technically, I'm multiplying by 1, but that doesn't change anything, so I don't have to do anything. Okay, so then I simplify that. I do 6 times 1, that gives me 6. 6 times 2 gives me 12, and then I bring down the 7/12. Okay, notice that we didn't change the fraction in any way. If we were to simplify 6/12, it would still give us 1/2. We're just manipulating it so we can add or subtract them together. So here, if we add these together, what's 6 plus 7? 13. So we have 13 over 12, and that would be our answer. And you would leave it as an improper fraction, or if, let's say, you converted it to decimal, that would be okay as well. For just fractions. You're not going to be able to do that on the other examples where we have expressions with variables in it. So we're going to do the same concept when we have some variables in here. So our first step is to look at the denominators and make sure that they're the same. So are they the same here?
Yes.
Good, they're both 5p. So that means I can just add the numerators together. So what's 2 plus 7? 9, and then I just bring the 5p over. That's my answer. I'm not adding the denominators, right? As long as they're the same, I can just write that new denominator in my answer. Okay, so I wouldn't confuse this and write 10p. I'm not doing 5 plus 5p. I'm just adding together the numerators. Okay, so let's get gradually harder here. Okay, so now we have these two rational expressions, and we're still checking if the denominators are the same. Yes, they're both 3d plus 5. So we're going to do the same thing, and we're just going to add the numerators. So what would be 2 plus 7d?
9d.
Okay, so some of you are saying 9d, and some of you are saying 2 plus 7d. So remember, we can only combine them if they're like terms. So since the 2 doesn't have a d as well, we just have to leave it as 2 plus 7d, or I heard someone say 7d plus 2, that's correct as well, over 3d plus 5. So that's our answer.
This doesn't have to do anything with reciprocals if it's negative, right? I mean, yeah, subtraction.
Correct. No reciprocals. That's only for dividing. Okay. So then we have this one here where, again, we see our denominators are the same. So I'm going to add the numerators together. Okay, so if well, actually not add, I'm subtracting now. Subtract those two numerators. So what would I get at the top?
This would be x squared minus 5x plus 24.
So this minus here has to go to both of these. Right? So this is x squared minus a negative 5, which turns to what? If a positive. So this is x squared plus 5x. And then we have minus a positive 24. So that's negative 24. Okay. Again, the reason why we're not combining anything here, because I heard negative 4x, I heard 5x cubed. We are subtracting, and when we're subtracting, we can only combine like terms. Okay, so x squared and negative 5x are two different types of terms. One has x squared and one just has x. Okay. And so then I would bring down, since I have a common denominator, x minus 3. Okay, before I say this is my answer, I should see if I could simplify further. Because notice in our other examples, okay, let's say like this example, is there any way to simplify 9 over 5?
No.
No. Was there any way to simplify any of these?
No.
No. But we're not sure if we can simplify this until we do what to the numerator? Factor. So that's what we're going to do. We're going to factor it. So the AC method, we do A times C, and that would give us,
Negative 24.
and then what is our B value? 5. And so can you think of two numbers that multiply to negative 4 but add to positive 5? Yes, 8 and 3 works. And which one is negative? 3. So 8 times negative 3 gives us negative 24. And 8 plus negative 3 is the same as saying 8 minus 3, which is 5. So those numbers work. And then since our A value is 1, can I go straight to writing my factors?
Yes.
Yes. So I'm going to write x plus 8, and then what would be my next one? X minus 3. And then I bring my denominator back, x minus 3. Now that we factored the numerator, can I simplify this in any way?
Yes.
Yes, what can I do?
Remove the x minus 3.
Remove the x minus 3, which means my answer is x plus 8. Okay, and we would not have known that unless we factored the numerator first.
In this case, Mr. Marcos,
Mm-hmm.
because negative 24, it's the same thing. If you did, it wouldn't, would it matter? Sorry, would it not matter if you put the 3 instead of making a negative 3, a positive 3? That wouldn't work.
It wouldn't work because if 3 was positive and 8 was negative, you're saying if we switch the signs?
Because are we using it to our advantage that we can move it around? We can use either or.
So there's only one answer for these ones, and it's going to be based on your B value. So as of now, if we have negative 3, 8 plus negative 3 gives us a positive 5, which is what we want. If we were to switch the signs and have negative 8 and a positive 3, if we add those together, that would give us a negative 5, which in this case, we only want positive 5 B value, so it wouldn't work if you switched it.
See, that's why we did that, the factor made 3 negative.
Yes. Yes. And I also could think, okay, well, since the bottom one is x minus 3, I know I have the potential to cancel out the x minus 3. So if you're thinking of, okay, what could my other number be, you could use that number on the denominator, which is that negative 3, and to think, okay, what number times negative 3 would give me negative 24 and still add to 5? So this is one of those where you could use it to your advantage here, that the denominator most likely will cancel out. I'm not going to say always cancel out because it could be a possibility. Let's say you factor this and your answer is just going to be all these factored, right? You wouldn't be able to cancel anything out. But majority of the time you will. Okay. So these ones were not too bad because majority of them had a common denominator. Okay, the same denominator. Now we're going to look at ones where they have different denominators. So they give you the steps here if you're that visual person and like to have this step by step. Okay. It says step 1 to factor the denominators, identify the LCD, which is the least common denominator. So it's the same thing we did with the fraction in the first part. Rewrite each expression with equivalent denominators, and then finally add or subtract the numerators and simplify if you can. So it's the same steps we followed when we combine two fractions, right? If we add or subtract two fractions. Except for these ones, it's going to be a little bit more complicated just because if you look at all these denominators, not only do some of them don't match, but some of them have to be factored in order to see if anything matches, especially like, for example, this one down here. But we'll start off with an easier one where our denominator is just numbers. So if we need to get a common denominator, what would be the common number between 3 and 2? 6. 12 could work. I heard 12. But we want the smallest number that they both can divide into. Okay, so 6 can go into 3 can go into 6, and 2 can go into 6. That's the smallest number. Okay, so what we're going to do is we're going to multiply each fraction by a number that's going to give us 6. So for this one, it's going to be 2. And this one is going to be what? 3. Okay, since the numerator has multiple terms in it, I want you to think as if you are distributing that number into the numerator. So for the first fraction, we have 2 times 2q, which is 4q. And then 2 times negative 4, which is negative 8, all over 6. Then I have minus, and then I'm going to do the same thing with the second fraction. So what's going to be on the top? 3q plus 3, and then, of course, over 6, because we wanted that common denominator. And since we're subtracting, we have to remember that that subtraction is going to each term. So we're not just subtracting the 3q, we're also subtracting the 3 within the numerator. Okay. So looking at the numerator, now that we have common denominators, I'm going to just write it out step by step. So we have 4q minus 8. I just wrote the first numerator. Minus 3q minus 3. So I gave that negative sign to both the 3q and the 3. Okay, this whole thing is over 6. And now I can look at this and combine like terms. So what could I combine first? 4q and negative 3q, which gives us q. And then what else? Negative 8 and negative 3, which is negative 11 all over 6. And then I would look at that. Can I simplify q minus 11 over 6? No, so that means this is my answer. Okay, so I got my common denominator by multiplying each of the fractions by the number that's going to give us that common denominator. Then I made sure to give the negative, since I'm subtracting, to everything in that second fraction, and then I combine like terms. Okay, so I would say this type of problem is more of a true type of problem that you're going to see. Because when we look at the denominators here, First off, we know that one is x minus 5 and the other is x squared minus 25. So they're not the same. But looking at x squared minus 25, we know we can do what to simplify? The perfect square, right? Perfect square, which means we take the square root. So what would be the two factors for this? X minus 5, x plus 5. So this is now gone. And in its place is the factor x minus 5, x plus 5. So now if I look at my two denominators, I'm going to ask myself, are they the same? Are they almost the same? What is that first fraction missing? The x plus 5. So in order to give that first fraction, the x plus 5, I'm going to multiply the top and bottom by x plus 5. Okay, so when I do that, x plus 5 times 1 stays the same. So this is just x plus 5. And then on the bottom, I'm not foiling this out. I'm just going to leave it as the factors. So x minus 5 times x plus 5. Okay, and then my second fraction stays the same because it already had both x minus 5 and x plus 5. So this is negative 10 over x minus 5, x plus 5. So now that I have common denominators, now what am I going to do? Add the... I'm going to add the numerators, x plus 5, and then it says plus minus 10, so you can just think of that as minus 10, right? So this is the same as saying x plus 5 minus 10 over x minus 5 times x plus 5, which we could simplify the numerator to be what on the top? X minus 5 over x minus 5 times x plus 5. Can we simplify more? What could we cancel? We could cancel the x minus 5. And since we canceled everything out of the numerator, what's left in that numerator? 1. So we have 1 over x plus 5. That's our answer.
What happened to the 10? I'm sorry?
The minus 10?
Yes.
We did 5 minus 10, and that gave us negative 5. Because we added the numerators together.
Yes.
Yeah, I put minus 10 instead of saying plus negative 10, because that's the same thing. Okay. Any questions so far? So that means even if they gave us more than 2 fractions, we would still go through the same process of making sure they all have the same denominator. So for example here, now we have 3 fractions, they're all subtracting. So looking at all my denominators, I have p minus 1, p plus 6, and then I have a quadratic that I need to do what? Factor. Okay. So that means I need 2 numbers that multiply to negative 6, but add to 5. What would those 2 numbers be? 6 and negative 1, right? Because 6 times negative 1 gives us negative 6, and 6 plus negative 1 gives us positive 5. So that means I can cross this out, and since our a value is 1, I can go straight to saying p plus 6, p minus 1. So notice that those factors match up with the other fractions' denominators. Typically they will, okay? So let's say you're stuck on the factoring part, then try out the factors that are on the other fractions, which you see is p minus 1 and p plus 6. Typically, those will be your factors for that quadratic. Okay, because our goal is a common denominator. Which means our common denominator is going to be both of those factors. So what is the first fraction missing? P plus 6. And then the second fraction? P minus 1. So in the first one, we're just going to leave that as P plus 6 and P plus 2 over P plus 6 times P minus 1, just like we do on the denominator. We're just going to leave those as two factors next to each other. If we need to simplify, we'll do that at the end. Okay, then the next one, so minus, this P minus 1 has a 2 on the outside. So we're going to think of that 2 as distributing inside that parentheses. So what's 2 times P? 2P. And what's 2 times negative 1? Negative 2. And that is over P plus 6, P minus 1. And then that last fraction doesn't change because it's our original fraction that had the denominator that we were looking for. Okay, so now that all our denominators are the same, then we're going to deal with just adding or subtracting our numerators. Okay. Which means we would keep this as P plus 6 and P plus 2. We would subtract 2P and then subtract a negative 2. So that would be minus 2P. What else? We're just looking at this step right here. So this minus 2P be turned into this minus 2P. But if, yes, I give that negative to the negative 2, that's going to be a positive 2, and then subtract the 14. Okay, I don't have to worry about giving this negative to the 14 because it's a term all by itself. We're already assuming that 14 is going to be minus. Okay, so this looks messy. Yes. So if we end up with something like this, okay, first, before we continue, tell me why I could not simply cancel out P plus 6. What about the parentheses?
You can't cancel it out because you change the denominator. Wait.
So at this point, we've already combined our three fractions, but there's a reason why we can't cancel out P plus 6.
Because it's straight up and down.
Not because of the straight up down. What'd you say?
Is it because they're both positives?
Not because they're both positives.
You just straight up solve the parentheses.
It's because we do need to solve the parentheses. You're thinking FOIL, right? Okay, but that's not why we can't cancel it out. We do have to do that step, but looking at that numerator, there's a reason somewhere in that numerator that tells us that I simply can't do this. Like, for example, let me go back to a previous one where we canceled. Right here. How did you know I could cancel out x minus 5 there? Because it's exactly the same, right? I only had one x minus 5. And then on the bottom, what was the operation between x minus 5 and x plus 5?
It was not on the top.
Multiplication. And there was only one on the top, and it's multiplication. So if I go back to here, our problem is our numerator filled with only multiplication. No, we have minus 2p plus 2 minus 14. So since it's not all multiplication, we can't simply cross this out. Okay? So again, this would be different if this was saying times negative 2p times positive 2 times negative 14.
Because it's not simplified.
Correct. So we can't continue until we simplify that numerator, which means, yes, we do have to FOIL those two parentheses on the top. Okay. So first foiling those parentheses, we do p times p and then p times 2. And then 6 times p and 6 times 2. So starting with the top, the red arrows, what's p times p? P squared. What's p times 2? 2p. Right, we want our number to come before our variable. Okay, then we do the purple arrows. What's 6 times p? 6p. And what's 6 times 2? 12. And I am going to move this so they're all on the same line. Okay. So that's just the foiling part. We still have to bring down minus 2p plus 2 minus 14. We had to bring down those last 3 terms. And now we have our 2 parentheses that are foiled. And then the last 3 terms just combining with what we foiled. So now we're still going through this and combining like terms. So what common terms can I combine? Negative 2p, positive 2p, and positive 6p. What's going to happen to those 2p's? They're going to cancel, so that means we're only left with 6p. So simplifying this further, we have p squared, because there's no other p squareds there to combine, plus 6p. And then what else can we combine? So 12, negative 14, anything else? The 2. Okay, so 12 and 2 is 14. 14 minus 14? It all cancels. It's 0. So this cancels, this cancels, this cancels. Okay, which means on our numerator, we have p squared plus 6p. Is there any way to simplify that further? To
Perfect squares.
not perfect squares. Nope.
Use it to remove a p.
Remove a p. Remove a GCF of p. So if we do that, we're left with p, and then what's in the parentheses?
P plus 6.
P plus 6. And then remember, this whole thing was divided by what?
P plus 6.
P plus 6 and p minus 1. Because remember, this whole process here that we were doing was just simplifying the numerator. Okay, we still have to continue to bring down the denominator with our answer. Which means now, can we cancel anything?
Yes. Yeah.
What can we cancel? And why can we cancel? Because it's multiplication. P is being multiplied by p plus 6. And p plus 6 is being multiplied by p minus 1, which means I can cancel them out. And I am left with what? P over p minus 1. That's my answer. That's super fun. Yeah. Okay, so typically when you have 3 fractions there and you're subtracting them or adding them, you will typically have this many steps, right? You will have the steps where you combine the numerator, you're going to have to FOIL something, combine like terms, and then simplify one more time to see if anything cancels. So now that I have my answer of p over p minus 1, why can't I cancel those p's?
Because the p is minus negative.
Because on the bottom it's p minus 1 and not p times negative 1. It's going to save you that skill in college algebra. Okay, so next one, looking at these 2 denominators, would you say they are the same? No, right? Because one is d minus 7 and the other is 7 minus d, which means if I was to rewrite this to where d was in the front, how would I write that? Negative d plus 7. So do you see how these are not the same thing? Okay. So what if I wanted to make that negative d plus 7 look like d minus 7? What would I have to do? Okay, if we yes, technically yes. We could multiply by negative 1. Or we would take out a GCF, right? Because our goal is always to try to factor. And by factoring, we take out a GCF. And what would that GCF be? Negative 1. So this is negative 1, and then we're left in parentheses, d minus 7. if you multiplied by -1, let's say you multiplied this one by -1, bless you. What you're doing is you're changing the problem. And when we take out a GCF of -1, we're just factoring. We're just simplifying it further. We're not changing the problem at all. Okay. So if this is our goal is to get both d minus 7. That means that first fraction is missing what? That -1. So I'm going to multiply. Because now we're saying, okay, this, yes.
How did we get to negative?
Because when we rearranged 7 minus d, we said that's -d plus 7, which we could factor out a -1 GCF, which means we're left with d minus 7. So that means our common denominator is not just d minus 7, but it's d minus 7 times -1.
Okay.
So that's why in order for that other fraction to match, we have to multiply the top and bottom by -1. So then that means we have -1, because -1 times +1 is -1. And then on the bottom, I'm just going to leave it factored like that. I'm going to leave -1 and then d minus 7. So then on the other side, I have 5 over -1 d minus 7. Okay, so now that I have common denominator, what am I doing with the numerators? Adding them. So what's -1 plus 5? 4. So I have 4 over -1 d minus 7. That's my answer. Okay, I could not necessarily simplify this further, but if I wanted to make this look a little nicer, maybe I could say instead of -1 on the bottom, I could just move it to the top, which means that would be -4 over d minus 7. Okay, that is going to be the same thing as what we just said. They just moved the negative to the bottom, we moved it to the top. So either way would be good practice to simplify when you have that negative.
I'm confused. How come we did not multiply? Sorry. So if we took out the GCF of -1 from 7 minus d, how come we didn't try to take a GCF out of the 5, but the other side was multiplied by -1?
Take the GCF out of the 5.
Yeah, I don't understand why the 5 didn't
Like,
go to
the number 1 and the d minus 7 got multiplied by -1, but the number 5 is left alone. And I don't understand why that was left alone.
Because we didn't multiply this denominator by -1. We took out the GCF of -1. So that means in order for these to match up, we would have to multiply the entire fraction by -1. Okay? We wouldn't just say, okay, only the denominator by -1, because now we're manipulated the fraction. Okay? We have to do both of them, because if you think of it like this, if you think of -1 over -1, those technically do what? Cancel each other out. So that's why we have to multiply both of them. But for the fraction with the 5, we're not multiplying that denominator by -1. We took it out of the denominator that was already there. Which means if I multiply that -1 back in, it's still -d plus 7, which is 7 minus d.
So the fraction is being, if we're finding the GTF of a fraction, we don't have to do it to the numerator, but we do have to apply it to the other fraction of the side.
Correct. And technically we're doing the same thing like on this problem here. When we factored this to p plus 6 and p minus 1, we didn't do anything to 14. Okay, because we didn't change the denominator, we just factored it. And when we take out a GCF, that's another way of factoring. But we did have to multiply these ones in order for it to match. And then same thing, we're multiplying top and bottom because technically these cancel out. Okay, so we're not changing anything. We're just manipulating it in a way for us to be able to simplify.
More factoring.
It's all factoring. GCF is factoring. AC methods factoring, perfect square factoring. Yes.
At the beginning of the concept, we had mentioned LCS, least common,
Oh, LLCD?
LCD creating.
Yes.
If that's only for, if we have whole number, no, not even whole numbers, right? Least common,
Least common denominator. All that's saying is, so remember when we were doing, I don't remember which one it was. One of them. This one. When we were doing this one, someone said, okay, the denominator that they could have in common is 12. Okay,
yeah.
which is true. We could multiply this whole fraction by 4 and this whole fraction by 6, and we would have a common denominator of 12. However, if we did that, we would have to do an extra step when we got down here to simplify.
Right.
And so the least common denominator is trying to avoid that very last step. So you need to think of the smallest number that your current denominators could divide into. And so for this one, it was 6 because 3 can divide into 6 and 2 can divide into 6. And like, let's say you can't think of a least common denominator. Just multiply the two denominators together. And that's your least common denominator. And that would be true for every single one. We could look at this one. Well, if we just multiply those two denominators together, that's our least common denominator. Okay. But I would save that till the very end. You want to try to understand the concept before just assuming, okay, let's just always multiply those together. Any other questions? I know this is everyone's always least favorite because it's fractions. Okay, one last concept, and that is using rational expressions in translation. So in other words, word problems. Okay, so for these ones, they want us to take these words, put it into a expression that we can either add or subtract, and then solve. So it says the difference of the reciprocal of n. So this difference tells me I'm going to have a minus sign. Okay. Then it says reciprocal of n. And we talked about reciprocal. What is reciprocal?
Flip.
Flipping it. But how do I flip something that's by itself? So technically it is n over 1, right? We just don't write 1 because n divided by 1 is just n. So good, if we were to flip this, the reciprocal, this would be 1 over n. So 1 over n represents the reciprocal of n.
So reciprocal means flipping.
Flipping. Mm-hmm.
Okay, but the reciprocal of n, the only way you could flip n is to make it a fraction.
Yeah, we convert it to a fraction by putting it over 1, and then we can flip it. And that would be anything. If they gave you a whole number, you just put that whole number over 1 and then flip it.
So that would mean that we're dividing, then putting it down.
Like when we put over 1? Like n over 1, you mean?
No, I think. Like, to answer this question, do we have to put it like in number form?
Like you mean like replace n with a number?
Like we're just putting down what the question is.
Yes, so just like we did on the previous one, where you guys were doing the applications and you were converting the words to mathematical terms, since it gives me n, I have to use n. And you'll notice once we set it up, what it's asking us to do. It's asking us to do the same thing we did in the examples above. So the next part says quotient of n and 3. So what does quotient mean?
Division.
Division. Quotient means to divide. So that means quotient of n and 3 means we're doing n divided by 3, which is a what? Would I write it like this? Would I write n divided by 3? How would I write it? N over 3. Remember, when we do fractions, that's the same as dividing. So technically what I have here is I have 1 over n minus n over 3. The reciprocal of n and the difference of the quotient of n and 3 is n over 3. Which means I can simplify this. Okay, so once I set it all up, I can simplify this because I need a common what? Denominator. And so what could be my common denominator between n and 3?
3 times
Three.
n and n times
3n. Right? Remember, if you can't think of anything, multiply them together. N and 3. So that means our common denominator, our LCD, is 3n. So if I want, and I'll write that off, the least common denominator is 3n, which means in order to make 1 over n have 3n on the bottom, what do I need to multiply this fraction by? 3. Just the bottom? Also the top. Okay, what would I have to multiply this fraction by? N. So then I have 3 over 3n, simplifying that first fraction, minus, what's n times n? N squared over 3n. So now that I have a common denominator, I can simplify this. What is 3 minus n squared? So we would just leave it as is. 3 minus n squared over 3n. Okay, because if you start to switch it and you say n squared minus 3, you're changing the problem. Okay, once we write it like this, if we wanted to make sure this was in the right order, we would put that negative n squared in the front plus 3 over 3n. Can anything cancel?
No.
No. Can anything simplify? No.
How about the reciprocal? And are we supposed to GCF that?
What do you mean?
Oh no, because it's a negative.
I mean, we could take out that negative, but the reason we don't like the negative there is because when we try to factor, it can mess us up. And since we can't factor anything here, we can't take out a GCF of n, we can't use that perfect square factoring, we would just say this is our answer. So I would say yes, if it looked like you could continue to factor, then I would first start by taking out the GCF of negative 1.
Would the answer be wrong if we just left it as 3 minus n squared?
No. For college algebra, that's going to depend on your teacher. For this class, it doesn't matter because we're learning the skill of subtracting rational expressions. And so if you get the skill down, it's fine. Okay. And then last one. It says the sum of 1 and the quotient of 2 and a. So starting in the beginning, what does sum mean? Plus. Okay, so it's saying the sum of 1 and. So we know we're going to have something with 1 plus. Then it says the quotient of 2 and a. So how would we write that?
Is it 2 over a?
2 over a, right? Quotient means to divide. We wouldn't write 2 divided by a. We would write it in a fraction as 2 over a. Okay, so this brings us to that situation before where we said, okay, well, we just had n. In order to take the reciprocal, we needed n over 1. We needed to convert it to a fraction. Well, here, in order to combine these two numbers, we have to turn 1 into a fraction. And how would we do that?
By multiplying it by 1a?
Not yet. Just putting it over 1.
Oh.
Okay, so first we got to turn it into a fraction. Then we would get the common denominator by multiplying it by a. Right? Because 1 and a gives us 1a, or we could just think of that as a. Which means the second fraction doesn't have to change, but this first fraction we have to multiply top and bottom by a.
Wouldn't that just be a over a?
Correct. It would just be a over a. So a over a plus 2 over a is going to give us
2a over a plus 2.
A plus 2 over
A.
A. That's my answer. And that's an A, not a 9, an A. Okay. Can I cancel the A's?
No.
Why not?
Because there's a plus.
We're adding a 2. We're not have multiply. If we had multiplication throughout, like A times 2 over A, then the A's could cancel.
Can you cancel when you're doing division too?
When we're doing, oh, I see, multiply or division. Well, then you're going to end up with what we did on the last notes, where you had like a fraction over a fraction. Then technically, you are able to cancel, but you have to first use the property of dividing by multiplying by the reciprocal. And then you'll cancel then. Okay, I think that's it. Yep.